you ever wondered what lies beyond our familiar night sky? What powers the brightest and most enigmatic objects in the cosmos? And could these cosmic giants hold the key to unraveling the mysteries of the universe? Join me on a journey through the cosmos as we dive deep into the world of quasars. What makes these tiny yet incredibly powerful entities tick? How do they shape galaxies, and what does the future hold for these cosmic phenomena? In this exploration, we'll answer these questions and more, taking you on a captivating voyage through the universe's hidden wonders. Let's go! The universe looks like a vast, empty ocean sprinkled with the rare islands of galaxies. But this is an illusion. Just a small fraction of atoms are found in galaxies, while the rest is thought to be drifting in between, in the intergalactic medium. Like the roots of some massive tree, gas spreads out from each galaxy, gravity funneling fresh mass into this dense cosmic forest. Here in the intergalactic medium are the raw materials of creation, hydrogen and helium, woven into sheets and filaments that flow into galaxies where they eventually create stars. But if we look closely, we see who's actually in charge. Quasars, the single most powerful objects in existence. As small as a grain of sand compared to the Amazon River, they reside in the center of some galaxies, shining with the power of 1 trillion suns, blasting out huge jets of matter, completely reshaping the cosmos around them. They are so powerful that they can reshape and even disrupt entire galaxies. In the 1950s, astronomers noticed mysterious loud radio waves coming from spots all over the sky. They were named quasi-stellar radio sources, or quasars, because they were dots like stars, but were seen in radio waves rather than visible light. Everything about them was strange. Some flickered, others emitted high-energy X-rays in addition to radio waves, but all seemed to be tiny. They also moved extremely fast, as much as 30% the speed of light. Guys, I just uploaded a short about the comparison of the speed of light from different observation points. Be sure to check it out if you are interested. And now, back to the video. The only explanation was that they were so distant that their apparent speed was actually the expansion of the universe, moving them away from us. These enormous distances meant that quasars couldn't just be stars. They had to be the active cores of galaxies billions of light years away. And it gets crazier. To appear so bright and loud, given these vast distances, they are thousands of times brighter than the entire Milky Way. Monsters, exploding and screaming into the void, with a violence not thought possible before. As we mapped the sky, we discovered over 1 million quasars, and they all seem to be very far away. Looking into space, far away means very long ago, because their light takes so long to reach us. Quasars were common in the early universe, having peaked in number about 10 billion years ago, when galaxies and the universe were still very young. Let's go back in time, just 3 billion years after the Big Bang, and see what was going on back then. How could an early baby galaxy be so bright and violent? All that light and radiation couldn't be stars, as there weren't nearly enough of them. And since galaxies tend to grow with time by merging, the starlight from small galaxies shouldn't be brighter than any galaxy today. There's only one way to generate the vast amounts of energy a quasar shines with: feeding a supermassive black hole. We still don't know how exactly they formed, but it seems like every galaxy has one in the center. But hold on, you might ask, how can the brightest things in the universe be black holes, which trap anything and everything that crosses their event horizon? Well, the light of quasars is not coming from inside the black holes. Rather, it comes from the space around them. A massive orbiting disk of gas, called an accretion disk. Quasars can use the same fuel as stars to shine: matter. It is just that black holes are the most effective engines for converting matter into energy in the universe. The energy released by matter falling into a black hole can be up to 60 times greater than that released by nuclear fusion in the core of a star. Because the energy released by a black hole comes from gravity, not from nuclear reactions. Matter falling into a black hole speeds up to almost the speed of light before crossing the event horizon, buzzing with an incredible amount of kinetic energy. In a space not much bigger than our solar system, the core of a galaxy can release many times more energy than all of its stars combined. And this is what a quasar is: a supermassive black hole having a feast. All these black holes eat a lot. Typical quasars consume 1 to 100 Earth masses of gas every minute. 10 billion years ago, the universe was about a third of its current size, so the intergalactic medium was much less spread out, meaning the filaments of gas around quasars could be feeding them a gigantic meal, making them vomit insane amounts of light and radiation. The brightest quasar power jets, tangling the magnetic field of the matter around them into a narrow cone. Like a particle accelerator, they launch enormous beams of matter out, plowing through the circumgalactic medium, forming areas of matter that grow to hundreds of thousands of light years in size. It's almost unfathomable in scale. A tiny spot in the galaxy carving out patches of the universe 100,000s of light years long. Quasars, these cosmic makeover artists, are busy reshaping galaxies. But what lies ahead? What other cosmic surprises await, and can we unlock the universe's deepest secrets? If you are into all things space, stick around for more cosmic discoveries. Hit that like button, share and subscribe to keep exploring the universe together. Until next time.